Sit down. All rise for the Honorable Judge Dalton. Get up.
Move, Avogadro.
Yeah, your mother.
You may be seated.
Peace.
We are swearing on the Book of Chemistry today. We are going to state the kinetic molecular theory today. A gas consists of a collection of small particles traveling in a straight line motion and obeying Newton's law. The molecules in a gas occupy no volume. Collisions between molecules are perfectly elastic. No energy is gained or lost. There are no attractive or repulsive forces between the molecules. The average kinetic energy of a molecule is 3 kT. T is absolute temperature. Before we move on, please let me remind you that an ideal gas is one that follows the gas laws at all conditions of pressure and temperature. Ideal gases differ most from an ideal gas at low temperature and high pressure. We may move on. In today's case, we have the prosecution of halogen by Boyle, Charles, Gay, and Lusac by breaking the gas law. I'll call Al Klein to the stand.
I was merely going on vacation with my family in the south of France. We were going hot air ballooning, okay? And halogen tells me, oh, this balloon is fine, it's safe, it follows all of the gas laws. However, that didn't seem to be true when my balloon plummeted out of the sky. Thank you for signing my cast, by the way.
What do you plead, halogen?
I plead not guilty. All my calculations were correct and I followed every single one of the gas laws.
Well, here's your sworn statement. Will you please repeat to us what it says?
Well, my calculations said that the balloon's flight would be perfectly safe. So it's obviously something this guy did wrong. Thank you. I had the gas at a pressure of 501 kPa and a temperature of 25 degrees Celsius, occupying a volume of 5.2 liters. To get the hot air balloon to lift off, the gas should have been heated to 100 degrees Celsius, increase the volume to 7 liters, and increase the pressure to 550 kPa. Those are all sound calculations and they are all correct, following all the gas laws.
The witness, you may now leave the stand, please. Thank you. We will now hear from the scientists.
I'm pretty sure it's supposed to be Gay Lusac, not Lusac Gay.
I guess you're right.
Thank you. So, Boyle.
Why do they call you Boyle?
I don't know. You tell me. Who has my name tag? Who? Oh, boy. Pull it up. There we go. Boyle. Excellent. So, clearly, this is an issue using my law that pressure and volume are inversely proportional.
Well, no. It's clearly using my law where volume and temperature are directly the same.
I think this is a case for our law that clearly states that pressure and temperature are directly related. Don't you agree?
Well, that's clearly not the only thing.
No, I think it's
Directly related. You two need to calm down.
But her law doesn't use volume, and your law doesn't use temperature, so clearly
But it's our law.
Our law.
Oh, what does your law say? Please
pressure
repeat
and temperature are directly
Yours
related.
doesn't use volume. Mm-hmm.
But
what? So clearly it is my law.
What is but your law does not use pressure, volume, and temperature. temperature during the grid? Where's the pressure? You tell me.
Well,
What does your law say, Boyle?
I told you already. This is why I'm superior to all of you. Okay? My law states that volume and pressure are inversely related.
But where's the temperature?
Ah!
I do not hear.
To all of you.
We have pressure and you don't have
Temperature.
pressure. I can't deal with this. I don't have to take this. I'm fabulous.
Dramatic much. Wow.
Ah, Boyle.
Your Honor, may I make a suggestion?
Please.
What if we combined their gas laws?
Objection! She's a girl!
Overruled. You go.
Alright, well, as my work clearly states, that 1 ATM equals 101.3 kPa. 1 ATM also equals 14.7 psi, and 1 ATM also equals 760 millimeters of mercury. Now, what the client was stating was that we have 501 kPa and a temperature of 25 degrees Celsius, which, by the way, he did not convert to kelvins, which is done by adding 273 degrees. Then we have the new formula that states if pressure 1 times volume 1 over temperature 1 times pressure 2 times volume 2 over temperature 2, then we plug in the information that we have, it would clearly come out to be 466 kPa, and he got the answer 550 kPa, meaning that his calculations were incorrect and he broke all 3 gas laws.
Jury is out. When they come back, we will see who is correct. Has reached the verdict, and you are guilty.
What? That is absolutely...
Ma'am, sir, please sit down.
I will not
Sit down.
Okay.
So, pretty smart for a girl.
Yeah, I guess.
I know I just met you, and this is crazy, but here's my number. So call me maybe.
Avogadro's number. 6.02 times 10 to the 23rd. How am I supposed to put that on my phone?
Hello, are you the Honorable Judge Dalton?
I am.
May I ask you a few questions?
Sure, sit on down.
All right. Reporter Clark Kent here, reporting from the chemistry courthouse in Chemistryville. Chemistry. I'm here with the Honorable Judge Dalton. Judge Dalton, what qualifies you to be a judge?
Well, first you have in the law of chemistry, to be a judge, you have to come up with your own law, and I came up with Dalton's law of particle pressure, where
And what is the law?
P total equals P1 plus P2.
That's really cool.
I try.
Is there anything else you would like to tell us about chemistry as a whole?
Yes, I don't know if you guys have heard of Graham's law, but it states that effusion, that the rate of effusion of a gas is inversely proportional to the square root of the gas's mass.
That's fascinating.
Again, Graham and I, we were BFFs.
I would like to meet this Graham.
He's hiding.
We'll find it. All right, thank you. This is reporter Clark Kent signing off. And live from New York, it's Saturday night!
of a gas is inversely proportional to the square root of the gas's mass.
That's fascinating.
Again, Graham and I, we were BFFs.
I would like to meet this Graham.
He's hiding.
We'll find it. All right, thank you. This is reporter Clark Kent signing off.